All right, welcome everybody to this AMS Weather Band webinar on the blizzards of 1978. My name is Tiernan and I work for the American Meteorological Society with the AMS Weather Band, which is our new initiative to connect weather enthusiasts to each other and to the cutting edge science of weather researchers and practitioners all over the world. So I'm very thrilled that you're all here with us today. I am especially excited to introduce our collaboration with the Blue Hill Observatory. And to introduce our speakers, Rob Thompson retired as meteorologist in charge of the Boston Norton National Weather Service Forecast Office at the end of April 2018. He received a Bachelor of Science in Meteorology from Florida State University and a master's degree in atmospheric science from the University of Washington. His career with the National Weather Service started as a summer student trainee at the Boston office during the early 1970s, and subsequent National Weather Service assignments included offices in Albany, New York, Anchorage, Alaska, Silver Spring, Maryland, and Reno, Nevada, before returning to the Boston area in November 1989. Our next speaker is Dr. William Minsinger. He is a retired orthopedic surgeon who was born and raised in Milton, Massachusetts. In 1980, he became involved with the Blue Hill Meteorological Observatory, which is a National Historic Landmark in his own hometown. He leads a nonprofit which now handles all observational work at the observatory, as well as STEM educational programming based on weather and climate at the Blue Hill Observatory Science Center. He has written 6 books and lectured on a number of historic weather events, including the 1938 hurricane, with a long interest in New England weather and climate. So I'm very excited to have both of these wonderful speakers here today. And I will hand it over to Dr. Minsinger. If you could unmute, and then we'll get started.
Hi, Tiernan. Thank you very much. So again, as Tiernan had explained, I grew up in Milton, and the Blue Hill Observatory is in Milton. But as a child, I never visited the observatory. It was always on a lot. So when I got back to Boston for my orthopedic training, I introduced myself to the observer at the time. And of course, we began to talk about the 1978 blizzard, which at the time had only occurred 2 years earlier. So it was really the weather event of one's lifetime if you were there in Boston or New England in 1978. So here are a couple of pictures of the Blue Hill Observatory, again founded in 1885, and that little inset picture shows the observatory in 1885 when Big Blue Hill was treeless. Trees have grown up since then because they put out every forest fire. But you see a 2-story tower there. That tower was replaced in 1908 with a 3-story tower. And next year, they're actually going to saw off the top of that tower, because over the intervening 100 years, with all the weather that occurs at Blue Hill, the cement in that tower needs critical repair. And they're actually going to saw off a portion of the top and replace that. So on the right-hand picture, you see that we're about 10 miles to the south of Boston. You see the Boston skyline there. And fortunately, we're in a large park. So that our environs really haven't changed very much. We feel like our climate record is a very good climate record, and actually the oldest climate record perhaps in North America, taken at the same location. So Bob, next slide. So again, we're here to talk about the blizzard of 1978. And again, I mean, it had it all heavy snow, high winds, but probably the most significant thing from this storm was the coastal flooding that occurred. So in the left-hand picture, you see the iconic picture, and this is right at Blue Hill. So Blue Hill, to get to Blue Hill, you take a turn on the access road off of Route 138. So you see Route 138 northbound to Milton, and just a mile and a half up the road is the access road to Big Blue Hill. So Big Blue Hill would be, Great Blue Hill would be off to your left here. And there is a long slope that comes up from Interstate 95 up onto Route 128, which I guess they call 95 now. But that long slope proved to be quite an issue in the blizzard of 78, and cars began to get stuck there in the afternoon of the start of the storm. And then they backed up for miles and miles behind that. So there was about 10 miles of backed up cars on the southbound side of 128, which is the circumferential highway around Boston. But what was amazing was, especially that night, we began to get reports of significant damage along the coast. And that probably is what this storm will be most remembered for. So Bob, next slide. So again, the 78 blizzard. So this was, again, the iconic photograph, Route 128, and this was taken on the 8th of February. But you see the little summary there done by the Boston Globe. And it was very true that in the afternoon of February 6th, thousands of people were sort of let out of work. And I believe that the state had sort of made a decision that they'd try to get everyone home and then get the snow fighting equipment out and clear the roads then. But what happened was the snow was falling so quickly, well over an inch an hour, and the winds were really howling, that 3,000 cars got stuck, 500 trucks, all stranded in Route 128, and it was complete gridlock. So that actually 14 people wound up dying that night from carbon monoxide poisoning as they sort of huddled in their cars, completely marooned in 128. But I like to say, and when we presented this at the 40th anniversary of the storm, if you talk about the 1978 blizzard, it wouldn't be wrong to ask which 78 blizzard, because the atmosphere was indeed prime that year. So the winter of 77, 78 was remembered in more than one location. So Bob, next slide. So here we were in New England, and there was a storm on the 20th and 21st of January, 1978. And there's the weather map. And that storm actually dumped 21.4 inches at Logan Airport and over 19 inches at Blue Hill. And I believe that was a new all-time record for Boston snowfall. This storm was not all that well forecast. But what was quite remarkable was that there was an intervening storm, which I'll talk about in a minute, that actually produced rain in Boston between that and the blizzard of 5 and 6 February, or 6 and 7 of February, so that all that was left was sort of the large snow piles and drifts. But that did make cleanup from the February storm more difficult. But a lot of the snow that fell was actually gone. So, Bob, if you could move that slide up a little bit, next slide, that's fine. I think there was 21 inches or 24 inches of snow on the ground at Blue Hill after this storm in January. So then next slide, Bob. And here was the intervening storm. So this was a tremendous gale through sort of the Ohio Valley and the upper Midwest. So again, this storm occurred on the 26th and 27th of January, and it was known as the Great Blizzard of 78 in the middle portion of the country, the Ohio Valley. So again, the barometric pressure here was the third lowest ever recorded in a non-tropical storm in the United States at 28.23 inches. And the barometer fell 40 milligrams in 24 hours. So on the East Coast, we talk about this cyclogenesis and bomb cyclogenesis. That's 24 millibars in 24 hours. This was 40 millibars in 24 hours. So this storm was really a tremendous storm. Over 40 inches of snow fell in Wisconsin and 20 plus inches from Kentucky to Michigan. And there were tremendous winds, wind gusts of 100 miles an hour. And I think over 70 people lost their lives. And there were 51 who died just in Ohio. So this storm would be remembered by anyone in the Midwest as the 78 blizzard. And they actually called it out there the White Hurricane because the winds were so fierce with such strong, heavy snowfall. So Bob, next slide. Next slide, Bob. Yep. So here is the Indiana National Guard in action. So again, the same thing sort of occurred here. The interstates were completely blocked, and I guess the Indiana National Guard had a tank unit. So you see a bulldozer there as well, but they had tanks, so they got the tanks out to try to move some of the trucks out of the way and get them moving. So whatever they could use in this type of storm was put to use. And again, people certainly remember this storm out of the Midwest as the blizzard of 78. So go ahead, Bob, next slide. So interestingly enough, here are my barometric tracings from my home in Milton. And you can see that the upper tracing was from January 26th. So again, that storm got down below 29 inches, even in Boston. But we were on the east side of the storm. The storm went to the west of us, and rain was the result here in Boston and washed away a lot of the snow that had occurred on January 26th January 20th, 21st in Boston. And here was my recording. The lower one was the barometric tracing for the blizzard of 78, which was the February storm. And you see that it got down to 29.50 inches, but that isn't all that remarkable for a storm in January, February in Boston. Next slide, Bob. So again, I'll go over a few historic storms in New England. So everyone talks about the blizzard of 88. But interesting enough, at Blue Hill, there was a coastal front that got set up just to the south of Boston. And Blue Hill wound up actually with 10 inches of sleet on the ground. Next slide, Bob. And you can see how that coastal front set up. So from Boston to Providence, Boston got 12 inches of snow or frozen precipitation. Much of that might have been sleet as well. And sleet occurred all the way down to Providence. But then to the west of that coastal front, there was tremendous snowfall, 47 inches in Albany, New York, 21 inches, or et cetera. So that this was a storm that was remembered for 100 years. But we would say that probably the 78 blizzard perhaps didn't eclipse this from the point of view of snowfall, but the amount of coastal damage that occurred made the 78 blizzard, the 1978 blizzard, such a memorable storm. Next slide, Bob. So here was Grand Central Station. They were cleaning out the yard after the blizzard of '88, and they brought all these dump cars in and loaded them up with snow and then pulled them out of the station. And it took quite a while to clear snow away in New York City and other major metropolitan areas. Certainly the rail lines were crippled for a few days. And again, this storm was remembered for many years. Next slide, Bob. So this is what telegraphy or telephone lines looked like with electricity in New York City before 1888, or the blizzard of '88. And a lot of these lines were taken down with the storm. So that's when power and telephone lines began to be buried in New York City because of the amount of damage. So much like Texas here recently, where the infrastructure didn't hold up very well with the storm, they decided the infrastructure had to be changed in New York, and they couldn't have these overhead power lines, in every neighborhood, that they were going to get into trouble again with them. Next slide, Bob. So again, in the Blue Hill archives, there's a paper that was written, Two Remarkable Snowstorms, by one of the observers, A.E. Sweetland, at Blue Hill Observatory. This talked about the winter of 1898, 1899. So again, in November of 1898, there was a very heavy snowstorm with the loss of the steam of Portland, with 191 lives lost. So that was a very rapidly developing northeaster. And the Sunday it occurred, this was Sunday after Thanksgiving. There were a number of people that wanted to get back to Portland. So the Portland ran as a steamship between Boston and Portland, Maine. And that was lost probably off of Thatcher Island and was swept down towards Provincetown. And they finally found it within Cape Cod Bay. So it lost power probably up around Thatcher Island, which is on the north shore of Boston, and it was driven down towards Cape Cod, where it was finally sank with the loss of all lives. And again, that storm had sort of the equivalent shorefront damage from the '78 blizzard. A new cut was made in the North River in Scituate, 141 vessels driven ashore, 280 lives lost in those vessels as well. So a tremendous amount of coastal damage from that gale. And then that winter, later in February, there was a severe cold wave, and the zero isotherm, it was zero, much like this cold wave in Texas, down to 31 degrees latitude. And there was a heavy gale force winds. And fortunately, sort of the severe cold had limited some of the coastwise shipping. So there wasn't as much loss of life from that storm. But I believe in this storm, and go to the next slide, Bob. I might have a map of this. No, this is another storm. But in that February 1899 storm, there was heavy snow at the 1 p.m. observation all along the coast from Portland, Maine to Charleston, South Carolina. And that was really quite remarkable. I would love to see that occur sometime again in my lifetime. You're not going to see that other than maybe once every 100 years. What happened there was, again, the cold air, the Arctic front was sort of aligned along the coast, and anything to the west of there was getting very heavy snow, and anything to the east of there was sort of in warm air. And the warm front, or the coastal front, backed up over North Carolina, Hatteras, and Hatteras shot up, the temperature shot up, I think, to 50 degrees. But then the cold front moved past, and even Hatteras, North Carolina, got snow. Next slide, Bob. So here was another storm. Again, not every February storm is a big snowstorm in Boston, but this is Boston's all-time February barometric low pressure of 28.48, and this storm came up sort of just to the west of Boston. Tremendous rain, tremendous wind-blown rain, and this storm would be remembered in New Brunswick and Nova Scotia as just a severe storm. This was really quite a gale that developed here. And Bob, the next slide. Up in Maine at Bangor, the Penobscot River actually flowed in and had a tidal surge. So they actually had a tidal surge in February, much like you'd see a tidal surge from a hurricane, because the winds were strongly out of the south. The tide came up, and the storm surge came up the Penobscot River. So this is downtown Bangor, Maine. This is well away from the coast with a tidal surge from this storm, and winds gusted to 116 miles per hour at St. John's, New Brunswick, and there was severe coastal damage in the Bay of Fundy. So again, not every gale is a snowstorm, but in February of '78, we had snow. So Bob, next slide. So again, here are the 10 top Boston snowfalls, and this was from 1/27/15. And you can go down the list and see that again, there were major snowstorms here. And again, the '78 blizzard is no longer the highest storm. So there was a storm in February 2003 that actually eclipsed that. But there were some certainly significant snowstorms. But the '78 blizzard is right up there with the heaviest of them. Bob, next slide. So again, one of the storms sort of was in that same category. This was the 100-hour storm in January of 1969. And actually at Mount Washington, there was 8 feet of snow that fell from this storm. And this is another remarkable storm in Boston. 26 inches, Portland, Maine, 26 inches, Concord, 28 inches. But these were over about 100 hours. So this was a several-day storm, and you can see some of the snowfall totals. And this actually, I think, ranked up as one of the largest storms or storms that covered the most geographic area and people, with over 24 inches of snow. So this red area, anything in this red area was over 20 inches or 24 inches of snow. So next slide. And then we had the storm of the century. So this was remarkable again in the sense that they got snow all the way down to Alabama, etc. But again, in New England, this turned out to be a significant snow, but not a record-breaking snowfall. Next slide, Bob. So again, why the '78 blizzard? So again, you see that there was a population here, in 1969, where a lot of people were impacted by a lot of snow. And then down the bottom of the list is actually 1978, where again, a lot of people were impacted by snow. But the interesting thing is that that's an impact with regards to how much snow affected people. But the impact from the '78 storm was so remarkable because of the coastal damage. So Bob, the next slide. So again, here were the stats from Boston: 26.7 inches, winds gusting to 83 miles an hour. Providence, 27 inches. Chatham, wind gust to 93. Central pressure, 29.06. Again, deep, but not the deepest storm ever seen in New England. And widespread impacts with 30 inches going from Rutland, Vermont, into eastern New York State. Catskills getting 25 inches. Albany only had 13 inches here. And then there was rain on the Cape. So there was again a coastal front in this storm, and anything to the east of the coastal front had rainfall, and that was about the Cape Cod Canal in this particular storm. Next slide. So again, here is the data from Blue Hill. So here are the record books from Blue Hill, and this is the one day in 137 years where the observer actually didn't make it up to the hill. He had recognized that when he left, that it was going to be very difficult to get off the hill. I think that was on Monday or Tuesday, I guess, and on the 6th. so that he prepared the charts to sort of run for more than one day because he was concerned that he might not get back up on the hill on the next day, which was true. He didn't get there. The roads were completely impassable, but luckily the recording instruments continued on. Now, interestingly enough, the wind gusts at Blue Hill weren't just that remarkable because the winds out of the northeast are not our strongest winds. The highest gusts for us usually occur with a southerly wind. And you can see from the chart on the right-hand side that the wind was north-northeast during the whole storm. And again, temperatures were hovering in sort of the upper 20s, lower 30s. Next slide, Bob. So again, here was a snowfall map from February 6th, 7th, 1978. And you can again see that there was a sweet spot just to the south of Blue Hill, from about Sharon, Massachusetts, down to Narragansett, the northern portion of Rhode Island. And that's really probably where the heaviest band really was. Now, there were some other localized pockets that were very heavy as well. And then you can see that, again, the cutoff was really on the Cape, and the major cutoff sort of just to the west of Cape Cod Canal. Next slide. So again, this is sort of an interesting photo. So the snow started at Blue Hill between 10 and 11 a.m. and then really came on very hard, really very quickly. So it sort of went from just a few flakes of snow to really heavy snow within a half an hour, perhaps. Here is a picture of a lady shoveling out her Volkswagen on the evening of the 6th of February. And I don't know exactly where she thought she was going to go because the road really looked pretty impassable. And this is a major artery in Morrissey Boulevard that the DCR or the MDC at that time usually took pretty good care of. But you can see that that road doesn't look like it had been plowed anytime recently. So I don't know exactly where she thought she was going to be going, but she was determined, I guess, to try to get herself dug out. Next slide, Bob. So here is downtown Providence. This is probably the 8th of February. You can see that, again, the same thing happened on, this is 95, downtown Providence, Rhode Island. Again, no one was going anywhere, and the cars were marooned down there as well. They probably had a little wetter snow down there. So again, the snow maybe packed in a little bit more densely there. Next slide, Bob. And this is downtown Boston. So there's City Hall Plaza with, massive piles up of snow, which they were able to push back. And then again, parts of the city really were very much crippled. And here were the U.S. Army Corps of Engineers mobilized, sent up to Logan Airport in C-130 transport planes. And they got their equipment out in South Boston to try to help clear the streets there. And my street in Milton, suburban Milton, we were probably 3 days or so before finally a bulldozer from the town dump, they got that out to open the roads initially and then plow back the snow from there. But there was so much snow that a regular plow couldn't really open the road. I had about 28 inches, I think. And again, they had to use a bulldozer to break the road open, and then plows could sort of plow back the snow from there. Next slide, Bob. So Bob, can you use your cursor there and show where Blue Hill is? Yeah, so that's the top of Blue Hill right there, Great Blue Hill. And then go down to Route 128, the interchange there. And right there, right where that little mark is that says 128, is where that picture was taken. So the section to the left here is that long hill that comes up from 95, which is just above the key there. So there's 95 a little bit further to the left, and there's 128. So that's where on the southbound lane, all the cars get stuck. Now, I happen to be going to medical school at the time, and I came up Route 24. So Bob, if you go over to Route 24, I came up and got on the southbound lane of 128 at about 4:30 or 5 o'clock at night and wondered why there were no cars on the road. And that was because the cars had already gotten stuck back on the slope up at Great Blue Hill, and no one was getting past. So I was essentially by myself on Route 128 with about 12 inches of snow on the ground. And I was able to then get home just a few streets further into Milton here. And I felt very fortunate that I actually made it home and didn't spend my evening and night stuck on 128. And that was just by luck. So Bob, do you want to take over here with regards to the coastal damage? Oh, Bob, you need to unmute.
All right, thank you, Bill, and good afternoon, everyone. I'm going to talk about the coastal perspective of the blizzard of 1978. And although this is New England centric, the presentation for the most part, there are certainly aspects of this presentation that can apply to other sections of the United States coastline. So if you're outside of New England, but near the coast, anywhere in the US, there's some application. A few of the concepts taught here will apply to you. And when we do think of the blizzard of 1978, especially people in New England, we often do think about these iconic pictures of heavy snow and vehicles stuck in the snow on major highways, such as Route 128 that Bill described. But there's also this aspect of the storm, major coastal flooding and considerable coastal destruction from the waves, coastal flooding from the high storm surge, water being washed on shore, and the destruction of structures from the high waves that were on top of the storm surge. And we'll talk about that. I myself was stationed at the Albany Weather Service Forecast Office. I was a meteorologist intern there, which was on the fringe of the storm. We got about 13 inches there. However, my parents lived in Cohasset on the South Shore, about 20 so miles southeast of Boston. But they were visiting a relative the weekend before the storm. I called my dad just to assure him that he needed to get home by Monday morning due to this storm. And he said, okay. He said, is it really going to be that bad? And he said, yeah, I think it's going to be quite bad. It's going to be a major storm. He said, it's not going to be as bad as the one in January. If you recall Bill talking about that one, and said, actually, I think it's going to be worse than that. When I saw him in April to help clean up debris from the storm, he confided me that he really thought I was maybe a little bit, hyper young, excited meteorologist, and so he really didn't think it was going to be that bad, but indeed it was. And while they're helping my dad clean up debris, he gave me a tour of the neighboring town of Hull, which is along the coast. And this sticks in my memory forever since, was the debris piles I saw, especially along Atlantic Avenue in Hull, from the homes that were destroyed there. It looked like a tornado had come through. It's really just what I would envision going through a scene after a significant tornado, and EF3 or EF4, something like that. And then when I came back to the area back in late 1989 to be the meteorologist in charge of the Boston Weather Forecast Office, it wasn't too long after that we had Hurricane Bob make landfall in 1991 with major coastal flooding, destruction along the New England South Coast. And then there was the October 1991 storm, so often referred to as the perfect storm, which had coastal flooding and destruction, which was really comparable to the blizzard of 1978. Not quite as bad, but it was pretty close. And so that has really was a motivator for me to take a look at coastal flooding in more detail, the science of it, and to work with my staff to see ways that we could enhance the forecasting of those events. Now, when we're talking about forecasting a coastal flood event in this neck of the woods, we're usually looking at the formation of a nor'easter, like the blizzard of 1978, which developed very rapidly. Now, this can be a complex topic, but really to make it very short and sweet, nor'easters essentially form when we have winds aloft. This includes the jet stream that then flows over a area of very sharp low-level temperature gradients, really sharp difference between warm and cold temperatures. This occurs quite a bit during the winter off the East Coast because you've got warm air over the Gulf Stream. But you also have very cold, often Arctic air over interior of North America. And where they come together just off the coast, we tend to naturally have an area of a very tight, very sharp temperature, low-level temperature gradient. And when the jet stream should dip, you get that wind energy aloft that dips to the south and crosses that temperature gradient, especially if it's curving as it does so, then that unleashes the potential energy that's contained in that tight temperature gradient, and basically converts it to the kinetic energy of a major coastal storm or nor'easter. Now looking at the 1978 in particular, that morning of Monday, the morning of the storm, when it began, you could see, if I use my cursor, that might help a little bit, you can see this is an upper, what we call a shortwave trough, meteorologists would call dropping into a broader, what we call long wave trough, tends to be a quasi-stationary wave. But this is moving on into this broader trough. Quite a bit of energy. These lines are what we call contours. They're equivalent to pressure lines, lines of equal pressure, and they're pretty tight together, indicating a lot of wind energy with this. 12 hours later, when the storm was really ramping up and really in its full fury across southern New England, you could see this energy starting to move off the coast. And once again, going across that low-level temperature gradient to really get the storm cranked up. This is a surface weather map. Indeed, the storm intensified rapidly south of New England. And an aspect of why the winds were so strong was not just, as Bill mentioned, it was a pretty intense low pressure center, but it was not really that extraordinary if you just look at the central pressure of storms that we've had in New England. But what made it very significant was the combination of a relatively intense low pressure and this particularly strong high pressure over south central Canada, centered over south central Canada. This is really quite strong, 1048 millibars. And it's that really difference in pressure that really drives the wind speed. And what happens is air will try to flow from high pressure to low pressure. And sort of think of a contour map for a moment. The lines of a contour map, when they're very tight together, that suggests very steep topography, a steep hill. And water that's going from a hill to the valley and crossing those tight contours, it's going to flow very fast. It might be almost like a waterfall. Well, the same thing happens with in the atmosphere. Air is trying to flow from high to low pressure. And if it's a really significant difference, it's going to tend to flow very rapidly. These lines that you see are isobars, lines of equal pressure. Because of the rotation of the air doesn't flow directly from a high to a low pressure, but kind of spirals out clockwise from a high pressure area and then spirals inward into a low pressure area. And given that counterclockwise flow across a low pressure area, the winds that we're having north of the storm are coming from the east-northeast. So very strong east-northeast winds and over a significant stretch of ocean. As you can see here, that's what we call a long fetch. And that allows the seas to build up, and it's driving the water onshore onto the shoreline to produce the storm surge. And in addition, because of this strong high pressure area, the center of the storm, the low pressure area, really couldn't continue moving northward. It stalled out for more than 24 hours, kind of blocked by this high pressure area. And consequently, we had these strong winds over a long stretch of ocean going for a long duration. In fact, there were multiple high tide cycles that were impacted too in particular. Also, it turns out that this was the time of the new moon. When we have a new moon or a full moon, then the gravitational pull of the from the moon is aligned with the gravitational pull from the sun. And hence we tend to get a greater tidal range during that time. In contrast, if it's a quarter moon, then they're really offsetting each other to some degree, the gravitational pull of the moon and the sun. The moon's gravitational pull is felt more strongly on the Earth, but the sun's gravitational pull isn't that inconsequential. So when they are acting together, we do get those higher tides. And that was the case for the blizzard of 78. It produced, given that very strong onshore wind for a long duration over a long fetch of water, it produced a storm surge of over 4 feet above this relatively high astronomical tide, or what we call spring tide, when we're in a new or full moon phase. And indeed, this set a new high water mark of 15.1 feet above mean low water in Boston Harbor. This is the highest recorded since the tide gauge was established in 1921. Now, this was eventually exceeded by a little less than an inch on January 4th, 2018. And we'll briefly talk about that event a little bit, how it compares to the blizzard of 78. Very significantly, it was those winds acting over a long stretch of water for a long duration not only brought water on shore to and resulting in the storm surge, but it also produced very high seas of what we believe were 30 to 35 feet. We didn't have the buoys off the coast like we do now, but there were Coast Guard reports that suggest seas were of 30 to 35 feet. And in fact, and these were very, very destructive. So when you have those high seas on top of that storm surge, bringing the waves onshore more than it would be if we didn't have a storm surge, they were extremely destructive, with over 2,000 homes destroyed or damaged beyond repair, and over 10,000 homes damaged at least to some extent. It was the Massachusetts East Coast that had the greatest damage, both the North Shore and the South Shore of Eastern Mass. This is a trace of the tide cycle that included the time period of the blizzard of 78. The green line is what the actual tide level was, what the total water level or the storm tide. And the blue line is what the astronomical tide was. So if we didn't have a storm, the tide would have traced out close to this blue line. But when you add the storm surge, then we got what was the green line. And you'll note that there were two high tide cycles that were very significant, and both were destructive. It was a little bit higher on the second high tide mid-morning on Tuesday, February 7th. And also by then the waves had built up a little bit higher as well, and also with a somewhat what we call longer period. If you were sitting on a buoy and a wave crest goes by you, the time to the next wave crest is what we call the period, generally measured in seconds. And by the time we got to that second high tide, we were looking at periods of the order of 13, 14 seconds or more. And those tend to carry a lot of energy, so those waves are especially destructive. The purple line is the storm surge itself. And the storm surge was actually probably a little higher for the first high tide, but it was astronomically not quite as high. So the total water level was not quite as high as the second one, but still very high and destructive. And that surge it may have relaxed just slightly, but it remained really quite elevated through that next high tide cycle. Hence, two major impact coastal flood and destructive wave events for those two high tides. Here's an image of Peggotty Beach in Citrus. It's a frequent flooder. and really was pretty much demolished for the blizzard of 78. Folks built back, and the October 1991 perfect storm pretty much wiped out most of the beach. Once again, it's been partially built back after that, but definitely a very vulnerable area. And the North Shore was impacted as well as this Revere Beach. Ocean Avenue, I guess, is an apt name for the area. Hampton Beach in New Hampshire, Plum Island in Massachusetts, Rockport Harbor, famous shack, motif #1 that was destroyed in the 78 blizzard. And to the south, over Outer Cape Cod, another kind of famous, very small structure, Henry Beston's famous Outermost House. And he wrote about staying a year there, and that really kind of prompted the designation of the national, or helped prompt, at any rate, the designation of the national seashore over the Outer Cape. This house survived, although fairly exposed, it survived many storms, excuse me, for a number of decades into the blizzard of 78, which then took it out and destroyed it. But more tragic was the loss of the pilot boat Can Do. Excuse me. Let me get a little liquid. There was a Greek tanker that perceived to be find itself foundering on in Salem Sound, and they contacted the Coast Guard for assistance. The Coast Guard sent a boat, but it too got into trouble in Salem Sound, and that prompted Captain Frank Kirk and his crew of the pilot boat Can Do to head out in the teeth of the storm to try to help out both vessels. Now, as it turned out, the tanker eventually managed through the storm, and the Coast Guard boat also was able to eventually reach safety. But the Can Do foundered itself overnight with the loss of all 5 crewmen. Now, I mentioned we might briefly talk about the January 4th, 2018 storm, because that exceeded the high water mark from the blizzard of 78, albeit by only about 3/4 of an inch. The storm surge for that storm actually was a little less. It was around 3 feet than the blizzard of 78, which was closer to 4 feet or 4 feet plus. But the reason the high water mark was higher, the astronomical tide was still higher. Now, there was a full moon, I believe, with the January 4th, 2018 storm. But what made for the difference was the fact that it was not only a full moon on January 2018, but the moon was in perigee. It was closer to the Earth than it was for the blizzard of 78, and hence the astronomical tide was about a foot higher. And that helped bring it up slightly over the prior record of the 78 blizzard. But significantly, where seas were 30 to 35 feet for the blizzard of 78, they were closer to 15 feet for the January 4th storm. So although there was widespread flooding with that storm, we didn't have as much coastal damage because of the lower wave heights. Now, if we look at a graph of, or bar graph of storm surges, the top, a little over top 10 here. The 1978 blizzard was actually stands as number 8 so far. Probably will eventually drop as we get bigger storms in the future, but it stands at number 8 right now. The highest one you see in 2010, for those of you who live in the greater Boston area, that may not ring much of a bell to you. And that was a 6.5 foot surge. And say, well, how come there wasn't a great deal of destruction then? The reason being is that surge occurred a few hours after the high tide. It was a very short duration surge. It was produced by very strong easterly wind gusts of 70, 80 miles per hour into Boston Harbor that produced that 6.5 foot surge. So certainly a sobering moment to see how quickly that surge can come up. Fortunately, we dodged a bullet in that it occurred a few hours after the high tide. So the result was actually getting a second high tide a few hours after the first high tide, which you almost never see. That is extremely rare to see that. But again, fortunately, it didn't occur at the time of the high tide, or that date of that night actually would have be something much more memorable. Now, we've touched upon waves a little bit. Waves do matter, and there are three ways that waves really impact the coastline. One is direct damage, structural damage from wave battery, the waves actually slamming into structures. Another is the greater inundation via overwash. That's the waves running up the slope of the beach and then going right over the barrier beach, often at very high velocity, doing some damage itself and into the area behind the barrier beach. And then a third factor would be scouring and erosion, which can, of course, be very significant. And sometimes we'll have homes destroyed that way because a bluff that a home will be on will be eroded away. In fact, we had a fairly recent example of that on the Cape and Sandwich. Now, to illustrate, though, that inundation from the wave run up and the wave overwash, take another blizzard of February 8th through 9th, 2013, and you're seeing a trace of the tide for Situate Harbor, Massachusetts, about 25, 30 miles southeast to Boston. And if you notice, we have a Friday evening high tide and a Saturday morning high tide of comparable magnitude. So the high tides were pretty similar. I'd ignore this one little bump up here. That was probably some wave action, but the water level itself was really quite similar for those two high tides. But for the evening tide, we had waves of 15 to 20 feet, significant just offshore. But for the morning high tide, waves were considerably more significant, on the order, like the blizzard, of 78, 30 to 35 feet, and also with those longer wave periods. Well, there are very high energy waves that were coming in. So this picture, if you look at to the right, look at the picture to the right. This was taken a few days after the February 8th, 9th storm. Water still hadn't drained yet, but it so happens that that water level you see, we think was probably pretty close to the water level with that first high tide that evening of February 8th. But with the higher wave action and that water coming over, more water coming over the barrier beach, it brought the water level up quite a few feet higher to the level of the where the ice, the bottom of the ice on the telephone poles. So that really was a good high water mark for us for the February 9th, that morning high tide. And so this difference was really in large part due to the waves themselves and that overwash from the waves. So that can be a very significant factor. And then timing can be important as well. This is another significant storm that we had in 2015. In fact, this January 27th storm was the first of four major nor'easters, major snowstorms that we had in Boston, producing over 90 inches of snow in 30 days. So that's a remarkable event in itself, a story for another time. But for January 27th, it did produce moderate to major coastal flooding. Here's another tide trace for you. The red line is the total tide or total water level or storm tide. There was one particularly high tide near 14 feet and this produced moderate to major coastal flooding. The blue line would have been the astronomical high tide, and the green line is the storm surge. Well, the storm surge at the time of the high tide was about 3 1/3 feet. Really quite significant. But if you will note the green line trace, the storm surge keeps increasing and actually peaked about a half hour after the coming low tide at 4 3/4 feet. Thus, had that storm been about 6 hours faster and we had the peak storm surge at the time of the high tide, you add it together, we would probably have exceeded the blizzard of 78 and the January 4th, 2018 high water mark. It would have been a record high water mark in itself. And if you want to take this a little further, if the storm should have occurred the week before when we had a 12-foot lower low water astronomical high tide, case where we were in either a full or new moon, so it was a spring tide, and also with the moon relatively close at perigee. If that were to have happened, because that'd be a number of factors that would have to come together, conceivably would have had a potential storm tidal total water level of close to 17 feet, and much higher than anything that we have in modern record keeping, and likely would have had a huge impact, a particularly big impact probably on infrastructure in Boston to water that high. Certainly you can see a number of things would have to come together, relatively rare event. However, it's theoretically possible, feasible that we could see that. And with sea level rise, that probably the chances are at least to some degree increase that we'll someday have to experience something like that. So an important point, I think, is the fact that there's been quite an evolution of coastal flood forecasting and the response to the forecast since 1978. There's been major advances in the atmospheric models and wave models, storm surge models, much better understanding of wave run-up, and some work on modeling that wave run-up. And besides the science advances and technology advances themselves, we also made an effort to try to have better documentation of these coastal impact events, so that we have a better idea now when we're predicting a certain total water level and wave action as to what kind of impact in various parts of the coast we might anticipate, and which then in turn helps to respond more appropriately to a potential event. And that response is really is so much better today than it was, given the evolution of the partnership, the collaboration, coordination, involving weather forecasters and the emergency management community and other key decision makers. So we see much more proactive decision making ahead of a storm than we saw back in the 1978 era. We do have as a backdrop that rising sea level, hence raising the stakes, and conceivably meaning in the future we could be starting at a higher level with the potential for flooding. And of course that equates to the importance of preparedness, as important as ever. There's a New England style you see in your screen. And that preparedness is important for various threats. A threat to life most important. One of the concerns we have in southern New England, and this is shared, I know, in other parts of the country as well, is an inexperienced population living along our coastline. Our last really destructive nor'easter was December 1992. Not too long after that 1991 perfect storm. Our last landfalling hurricane in southern New England was Bob in August of 1991, and the last major hurricane landfall, Category 3, was Carol in 1954. And there's threat to property. Some property one can't save, of course, but some property can be moved up or out. Vehicles can be moved out, and also some property can be secured if it can't be moved ahead of a storm. And then there's the threat to infrastructure, particularly transportation, communications, and power infrastructure. Big issue for some of our major urban areas, such as Boston. And a real wake-up call for us in the Boston area was Sandy's impact on New York City, which really did a number on their infrastructure. Consequently, we have had some gatherings and exercises to try to identify some of those vulnerabilities and to try to be better prepared for when we have to deal with a Sandy-like storm, be it an extratropical nor'easter type of storm or a hurricane in the future. And certainly I think there has been some progress. You see in the picture there where water is threatening the MBTA station aquarium. I think there certainly has been some progress, but there is still more work, I'm sure, to be done. So in summary, From a coastal perspective, the blizzard 78 does remain a benchmark nor'easter. So it's a benchmark nor'easter, both from a snowfall standpoint and from a coastal flooding destruction impact standpoint. The coastal flooding and damage along the coast from the 78 blizzard and more recent storms are a reminder of our vulnerability, which of course is increasing still further with sea level rise. There's been great advances in the science and technology involved with the weather forecast process, as well as in the collaboration with emergency managers and that response to a potential storm threat. However, I can't stress the importance of preparedness enough, because there's an old Japanese proverb that states, natural calamity strikes at just about the time that one forgets its terror. This applies not only to coastal storms, but also to all types of severe weather hazards. And for that matter, you could include pandemics as well. So we thank you. And to the extent we have time, Bill and I would be happy to try to answer any questions.
Thank you both so much for that really wonderful talk. We had a couple questions come up in the chat. Let me scroll back to them. So the first one is it true that homes were smashed against the shore and burned in giant bonfires by the National Guard? So I guess that gets to debris cleanup. Were those homes that were smashed burned in bonfires?
Well, I don't recall that. Bill, do you know?
Yeah, I think by this time they weren't permitting bonfires. I won't say that no debris was burned, but I think a lot of it was trucked away eventually. But there was plenty of stuff to drag away, if you know what I mean. I mean, a lot of these houses, again, as Bob had alluded to, needed to be torn down as well. And that tear down process didn't necessarily occur immediately. That might have been the next summer. Some of these houses finally were torn down.
Great. The next question was about the satellite imagery on that slide you had, Bob, that was talking about nor'easters. So the question was, is that satellite imagery from March 2nd through 3rd of 2018?
Well, you know, I'm not sure where I gather that from. I don't, if it could have been. It's really similar to other satellite images we've seen of mature nor'easters, actually. It almost seems like there's an eye in the center, but it's actually drier air that gets wrapped around towards the center. But I'm not sure that the date. It looks like I didn't annotate it on the slide itself, and my memory isn't that good.
And but that was not the 78 blizzard. I mean, that's a more modern satellite photograph.
Right. No, it was after that, yeah.
All right, we also had a question for Dr. Minsinger. What type of car were you driving on Route 128 in 1978, and was it a rear wheel drive?
It was a 67 Chevy Nova Sport. It had rear wheel drive, but fortunately, and I had just bought the car a month or so before, about a week and a half before this storm, or actually it was before the 21st, January 21st storm, I bought a set of used snow tires. So I had snow tires on it, and it actually did pretty well in the snow. I must say, by the time I actually made it to my house, there was about 12 inches of snow on the ground, and I sort of gunned the thing and got it up the driveway at a 45-degree angle, and that's where it stayed for more than several days before we finally shoveled it out. And we finally shoveled the car out, but the street hadn't been plowed yet, so you couldn't go anywhere.
All right, the next question, do you happen to know if or how amplified the jet stream was in the February 1978 blizzard?
well, probably both Bill and I could address that, but yes, it was quite amplified with quite a bit of dipping to the or headed to the north in the western part of the United States, where there's a very strong ridge of high pressure, and then dropping quite far to the south. So it was quite amplified, and that's often the situation where we get some of our bigger storms.
And I would just add that whole period of time must have been an amplified flow across the United States because of the storms that were produced there for a 3 or 4 week period, much sort of like the 2015 snows in Boston, where again, every 4 or 5 days, there was a significant northeaster that came up the coast. Sometimes that can get going and repeat itself. The same pattern sort of repeats itself.
Yeah, often those that amplified nature of the jet stream is being caused by these quasi-stationary, what we call long waves. They're very big waves, big wavelengths, and they tend to be quasi-stationary, stay in one place. So sometimes a pattern will persist for 2 or 3 weeks like that.
All right, our next question. Could Bob imagine a storm surge warning being issued for a non-tropical nor'easter along eastern Massachusetts?
Well, right now we issue coastal flood warnings for an extratropical storm. There has been some discussion about issuing storm surge warnings and for a tropical system. Now, there are storm surge warnings that are issued, and there is a good argument that we should be consistent, because for most people, you're going to get impacted by if it's a tropical or extratropical storm. The fact is, you're going to be flooded with perhaps structural impacts from either one. So it is something we may see in the future, but right now, extratropical storms, nor'easters, are handled by coastal flood warnings, which imply there could be also significant wave action, whereas tropical cyclones, hurricanes, tropical storms could be covered by they would be covered by a storm surge warning.
All right, next one. Does the occasional mist forecast cause the public to regard predictions of blizzards as hype?
Well, I think, go ahead, Bob.
Yeah, I was just going to say, and I think you addressed it a little bit, because the January 1978 storm wasn't well forecasted, and I think folks were a little skeptical for the 78 storm. Now, I must say, in the intervening time, I think there is greater credibility in weather forecasts in general. Hence, you see schools that have been canceled because we may be in a new era now with remote learning, but that aside, schools are now canceled often a day ahead. You just didn't see that back in the 1970s. But certainly, if there's a missed forecast, then that can reduce the credibility for a forthcoming event, and so it's why we try to get them as right as we can. But some storms are more challenging than others, inherently so.
Yeah, I think in this particular case, again, that earlier storm, which wasn't well forecast, I think made perhaps the meteorologist a little gun shy. And I can remember seeing Don Kent. He was skeptical in the early morning forecast of the day on Tuesday, but finally at noontime, said that yes, he thought that there would be a significant storm. But it was interesting that the computer modeling, which was in its infancy at that time, the computer modeling was almost hard to believe. So that was one of the reasons why meteorologists were somewhat skeptical about predicting quite the storm that evolved, simply because they really hadn't seen anything like that from the modeling at that time. I think that's true, is it not, Bob?
Yes, that's very true. And actually, it was rather primitive modeling at the time, but it actually handled the event very well. About 3 days in advance, we could see it evolving. And it turned out to verify really, really well. That's not always the case, And back at that time, there just wasn't as much confidence in the model output. There tends to be more now than there was then. But yeah, it turned out to verify really extraordinarily well, really almost surprisingly well, given it was back in '78.
Yeah, someone just asked which models we were talking about, and there were only a handful of models, just maybe one or two models at the time.
Yeah.
But as I recall, the Boston Weather Service office on Sunday started talking about a storm of historic proportions for Tuesday. So they were on top of that second storm, although no one was perhaps forecasting quite the intensity that occurred.
Yeah, which is hard to do. It's hard to forecast something you haven't seen before.
Yeah.
That's really pushing the limits of climatology. But indeed, I believe the Boston office did a very good job of alerting to the fact that it would be a major storm. They didn't realize just how major it would be, but they knew it was going to be very, very significant.
All right, we had just one more question if you have time. You mentioned long wave amplification. Do you think there is greater amplification now with climate change occurring, which has been suggested by some climatologists?
Yeah, that is an interesting question. There is some discussion, particularly among climatologists, and this is where climatology, meteorology almost start to come together. There is kind of this transition zone. And that's that when the polar vortex is disrupted more, which seems to happen more frequently given the climate change that we've been experiencing, there seems to be some linkage. I'm not an expert in that area, but there seems to be some linkage. And when that happens, that does sometimes result in a displacement of that vortex further south at a more southerly latitude, and that in turn can produce that greater meandering of the jet stream, greater amplification, and sometimes set the stage for some more significant storms.
All right, we actually had two others if there's time for those. From Bruce, how large was the temperature delta across the coastal front, say from eastern Cape Cod to Boston?
Yeah, Bill mentioned the coastal front. Bill, you jump in if you want, but it's.
Yeah, I think it got into the 40s on the Cape, and it was really an all-rain event on the Cape. Charlie Olaf, the Blue Hill executive director, was on the Cape and got skunked. I can't tell you exactly what the temperature difference was there, but there was a fairly significant contrast there. And again, I'm not so sure. I mean, there was always that rain snow question, but perhaps the '78 blizzard really got us thinking about coastal fronts, if you know what I mean, because it was so dramatic in this particular storm. I mean, you went from Plymouth, you might have had 6 or 8 inches of snow, to 36 inches of snow within a matter of just a few miles.
Yeah, Bill, we actually had a pretty dramatic recent case 2 or 3 weeks ago of a storm where we were seeing 12 to 18 inches just west of Boston, even over a foot as you got to the Route 128 belt. But along the immediate shore and the south shore, there was little to no accumulation at all. So in just the space of 20 miles or so, one went from no snow to 12 to 18 inches crossing that coastal front. It's caused by strong winds coming in off of the water, and there's less friction off of the water. So you may have like an east or east-northeast wind, but as the air goes over the land, there's more friction that tends to change the direction to a more of a northerly component, say north-northeast. And when that happens, it actually causes sort of a convergence. If you can try to picture more of an east wind and a north wind as they kind of come together, back from the coast a little bit. And that really intensifies the gradient of temperature. And where you're to the east of that front, you're getting milder ocean air more inland, the cold air over the interior stays locked in.
There's also a question on what the definition of a blizzard was in 1978 and if the storm really matched all those requirements.
It certainly matched the visibility having to be, I believe, less than a quarter mile for at least 3 hours. So for a sustained time, due to heavy snow and or blowing snow, and winds were certainly reached the criteria well over 40 miles per hour. And at that time, temperature may have been a factor. And actually, I'm not 100% sure of that, Bill. Maybe you know. I think
it still might have. Right, it still might have been that we didn't meet the temperature criteria, but for all intents and purposes, it met every other criteria for a blizzard. And I'll just tell a little anecdote. Again, I was at Brockton Hospital, and there was a physician who gave me a short lecture, and he said, "Well, I better give you a lecture, and you better get back on the road." So it was a slide projector, so we had to close the curtains. We pulled the curtains open, and both of our mouths just fell open. I mean, in the 45 minutes that he talked to me, we probably got four or 5 inches of snow. And by that time, the wind was blowing 30 or 40 miles an hour. It looked like a blizzard. And he said, "Well, you better get back on the road if you think you're going to get home." And it was amazing. And that's what created all the trouble on the roads. The snow began and really fell hard right almost from the beginning, and the winds kicked up. So, you know, they were already drifting the snow just an hour or two into the storm.
All right, and our very last question. Thank you for answering all of these queries. Did U.S. meteorologists learn from the 1972 blizzard in Iran that produced 26 feet of snow across a week in February 1972?
Well, I'm sure there are research papers on that event, but I'm not familiar with the details of that event. It sounds, my suspicion was with that amount of snow, there was probably some orography involved, mountains involved, and uplift from the mountains. We see some phenomenal snowfall rates in the western mountains, and Bill actually mentioned a pretty significant effect of topography in New England with the 69 storm that dumped 8 feet of snow over several days and 4 feet, I think, in 24 hours, if I recall from your slide, Bill, on Mount Washington. And so some of that really heavy snowfall was a contribution to that was the wind, moist wind flowing up the side of the mountain range, and that kind of squeezes the moisture out. No matter how you get upward motion, that tends to squeeze moisture out of the air mass. And it's done a variety of ways with fronts that can push air up, with air converging into low pressure centers, with instability where the air tends to want to rise on its own. We see that more during the summer. But another factor can certainly be mountains, and the flow going up the mountain can really cause very strong upward motion and particularly heavy precipitation, which can be in the form of snow. And we see that quite a bit out in the western mountains, but to some extent even here in New England.
Great, thank you so much. And that wraps up our questions. And I just want to thank you so much for this wonderful and incredibly educational talk, and for sharing your own personal experiences with us. So on behalf of the Weather Band, thank you to all the participants and to our speakers. Thank you for sharing all of your fantastic personal experiences and helping us to celebrate and expand the world of weather. So with that, I will say goodbye and have a wonderful rest of your day.